This glowing screen represents the functional reality of the modern smartwatch ecosystem. It is hardware strictly dependent on the smartphone in your pocket. The current crop of wearable devices faces a consistent set of criticisms from hardware reviewers. They are highly priced, they demand daily battery charging, and their standalone utility is limited. Today's wearable is essentially a proxy device. It acts primarily as a secondary miniature screen built to mirror a larger gadget's notifications and alerts. Despite the illusion of advanced wearable computing, the modern smartwatch is a tethered smartphone accessory, not an independent machine. This dependency was not always the baseline assumption. In the mid-2000s, smartwatches were engineered to be fully independent, standalone devices. The Dick Tracy smartwatch serves as the primary case study for that earlier era of wearables. The underlying architecture powering these early devices was Microsoft's Smart Personal Object Technology, or SPOT. SPOT was a standard designed to embed computing capabilities into everyday items. It was Microsoft's early, ambitious vision for an Internet of Things ecosystem. They envisioned an array of smart devices, scaling from wristwatches to coffee makers, communicating without relying on the traditional internet. The SPOT initiative demonstrates that pioneering a product category and executing a clever business model means nothing if your infrastructure timing is wrong. Building a continuous Internet of Things network years before the widespread availability of the mobile internet presented a specific technical hurdle. SPOT engineers did not have access to the ubiquitous connectivity we rely on today. There were no pervasive 3G or 4G networks, and standardizing around Wi-Fi and Bluetooth for low-power wearables was not yet viable. Microsoft transmitted their digital data over traditional analog FM radio frequencies using towering broadcast antennas like this one. On the right, a modern two-way mesh pushes data back and forth. On the left, the SPOT model, a radio tower broadcasting a one-way signal. This one-way FM infrastructure strictly limits the volume of data pushed to the end user. Infrastructure dictates product architecture. Because of the bandwidth constraints of FM radio, Microsoft had to build a platform that passively received the world rather than interactively engaging with it. The service layer behind this technology was called MSN Direct. Microsoft made a specific strategic choice here. They opted out of building the actual physical watches, positioning themselves solely as the data pipeline provider. That pipeline broadcast information in 3 tiers. The first was national data, which pushed broad updates like stock prices and major news events directly to the rest. The second tier focused on localized data, beaming regional weather updates and local movie times to users based on their geographic location. The third, and technically most complex tier, was personal notification data. As we see in this classic billboard ad, the system integrated Microsoft's MSN Messenger, delivering instant messaging alerts to the watch. The SPOT network also parsed professional data, surfacing Outlook calendar appointments on the user's wrist. This tied the ecosystem together. The MSN Direct service required a $60 annual subscription to keep the data flowing. Microsoft successfully built a high-margin, recurring software-as-a-service revenue stream decades before it became the tech industry standard, treating the hardware simply as a vehicle for the subscription. By utilizing OEM partnerships, Microsoft outsourced the financial risks of hardware manufacturing to legacy watchmakers. An OEM, or original equipment manufacturer, is a company that produces hardware that is then marketed or utilized by another company. This fossil storefront represents the caliber of legacy brands that signed on to produce the first wave of SPOT watches when MSN Direct was announced. Because MSN Direct handled the core data transmission uniformly across all devices, manufacturers were free to experiment and apply their own physical hardware features to differentiate their products. This Swatch retail location points to the brand's paparazzi model, a clear example of this hardware experimentation. The paparazzi model supported Swatch's radical internet time concept, a feature that abandoned traditional time zones entirely to divide the global day into 1,000 equal beats. Looking at this Tissot storefront, we see the premium execution of the platform. Tissot released the High-T model, which featured a high-end, touch-sensitive sapphire watch face to navigate the MSN Direct menus. Meanwhile, Suunto positioned their devices for the athletic market, incorporating hardware like heart rate sensors and water resistance down to 100 meters. While this strategy allowed for rapid iteration, it created a scenario where the physical experience of the platform varied significantly across brands. Because a Tissot user navigated by touch and a Suunto user used physical buttons to access the same data stream, the Spot platform lacked a unified, recognizable physical identity. In the mid-2000s, Microsoft achieved 3 strategic milestones: correctly predicting the IoT vision, executing a subscription service model, and securing massive OEM partnerships. This brings us to the central paradox of the Spot watch. If Microsoft nailed the strategy, why did their standalone device die out, while the dependent, tethered smartwatches of today thrive? This side-by-side comparison reveals the answer. The left-side Spot FM radio infrastructure simply couldn't scale to handle massive bidirectional data demands. On the right, modern tethered models sacrificed independence, shifting the heavy computing burden entirely to the smartphone. This tethered compromise solved the ultimate bottleneck of wearable technology: battery drain and high connectivity costs. The Spot watch illustrates that vision and a sound business model are insufficient on their own. Product success is ultimately gated by the realities of infrastructure timing.